Hi, this is Mrs. Zhu, and we're working on homework number 8, and we're going to be going through hopefully question number 20, the first question, number 25, and 28, and 29 in this video. Number 20, we're going to start with that. You're going to start with picking your x's. That's the first step we want to do, so we're going to create a little chart. Our x's that we want to pick, you really can pick anything. You want to pick 0, 1, and 2. You can always pick 0, 1, and 2 for every question. A lot of us were picking maybe just 1, 2, 3, is keeping everything positives. That's fine as well. I'm going to choose to use 0, 1, and 2, and I'm staying in the positives as well. The second column of my chart is going to be my equation. So my equation is y equals x plus 3. And that's the problem in number 20 that I'm graphing. And then the last part of the column is going to be the x comma y, our solution in our ordered pair that is going to help us then go to graphing. So I'm simply going to be plugging in our x's that we choose into the equation to then find the corresponding y value. So the first, I'm going to do y is equal to x plus 3. I chose 0 as x, so I'm going to do 0 plus 3. That will give me an answer where y is equal to 3. 0 plus 3 is 3, which then gives me the points where x I chose was 0, and when x was 0, y became 3 when I plugged it into the equation. So that's my first solution when I go to graph later. Okay, then I'm going to do that again for 1 that I chose. So y is equal to 1 plus 3, and mental math there. That's going to give me 4. So my second point is going to be 1 comma 4 equals to 4. So that's my second solution. I'm going to highlight that. Which means that the next solution, very easy, I'm going to do y equals to 2 plus 3, which is going to give me 5. So my second solution is 2 comma 5. So when I plugged in 2, the outcome was 5, my third solution. So I do need 3 dots when I go to graph on my coordinate plane. So in your homework tonight, you do need to make 8 separate, there's 8 problems, 8 separate charts. I definitely don't want to put it there. I'm going to paste in my little chart here. Uh-oh, having a little trouble here. As I draw my coordinate plane, I want at least 5 tick marks, so that's the greatest number that I see. So I'm going to do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. And I want to make my spaces as consistent as possible. So my first solution is 0, 3. 0, 3 is here on my y-axis. This is my x. 1, 4 means I go 1 for the x and 4 for the y, so that's here. 2, 5 means 2 for the x and then 5 for y. So I've got 3 dots in the same area. Good, perfect. I'm going to take my little ruler and then I'm going to connect them. And I don't want to just connect it like that. What I want to do is extend the line past the dots. Oh, my dot just dropped. And extend it past it with my ruler and then draw arrows representing that those are just 3 solutions, but really the entire line itself, as I've now graphed y equals x plus 3, this linear equation, there are many other solutions that are appearing all over the graph, infinitely to infinity and beyond, but I've got these 3 to prove that, hey, I knew how to draw my linear graph. Okay, so you're going to do that for every question, and you can pick, again, the x's that you want and the same x's over and over. I'm going to look at 25. 25 is tricky. I didn't have time to talk about it in class today, but as you're watching the video, you're going to get a little preview because I will talk about it more in class tomorrow. This equation does not have an x. There's no x in the equation. We talked about how our linear equations will have two variables. So how can an x be missing? Well, in this equation here, what it's telling us is that y is always -6. So if I were to make a little chart, an x and a y chart, then since y is always -6, I'm always just going to have -6 for the y's, which means that I can pick any 3 x's. Okay, so I'm going to pick any 3 x's like I did before, 0, 1, and 2, or the 3 that I chose. So I'm just actually going to go ahead and graph these 3 solutions: 0, -6, 1, -6, and 2, -6. So as I draw my coordinate plane, okay, I definitely want to have -6's down here, 2, 4, 6. How about that? -2, -4, -6. So there's my -6. I can put a few little tick marks here. Each one is going to be counting by 2's. -2. So I'm going to take 0 and go down to -6. That's the first dot, this one. Then I'm going to do the second one, 1, -6. 1 hits here, and -6 is down here. And the last one, I'm going to do 2, -6. So 2 is here for my x, -6 is down here. What I'm starting to see is as I go to connect these 3, I'm going to extend my line again, draw arrows. The graph that I get, I'm going to highlight that, is this line. And this line is the graph for y equals -6. It is a horizontal line. Okay, it's a horizontal line, and it's consistently telling me that no matter what x is, x could be like 10,000 all the way out over here, but I'll always go down -6 for y's. Okay, or if I have like thousands and thousands of numbers, or -1,000,000, then I'm always going to drop down to -6. So this line that ends up to be horizontal is telling me that the equation means that no matter what x is, y will always be -6. Okay, that's 25. And number 28 is very similar, but instead of y equals something, x is equal to 7. So here, no matter what y is, x is always 7. So if I were to do a little mini chart with just x and y, the x this time is going to be always 7. So I'm not really allowed to, for this equation, pick my x's, because it's telling me in the equation that x is 7 all the time. But I can pick my y's. I can pick y's, okay, meaning y's will change. So I can have like 0, 1, and 2 for the y's. So when I go to graph, I've got these 3 solutions: 7, 0, 7, 1, 7, 2. So in my graph, what we will see, and the x is a 7, so I want to make sure that for my x, that I'm going all the way out to 7. 1, 2, 3, 4, 5, 6, 7. 7. And then I'll just do 1, 2, 3, 1, 2, 3, 1, 2, 3. -3, -3, +3. 3 here. Okay, so I've got 7 all the way out here. So when I go to graph, I have 7, 0. So there's 7, 0, the first dot. 7, 0. 7, 1. 7, 1 means 7 out here, but 1 up here. And the third dot is going to be 7, 2. So we've got 7 to the right and then up 2. So now what we'll see is when we connect our dots, again extending it, drawing arrows. Okay, we're going to highlight that. What I see now is different than the last example we did, because this is a vertical line. And this vertical line shows me that, hey, no matter what my y-axis number is, x is always going to be 7. Okay, now when we look at two variable equations, x's and y's represent two different things in real life. So it could be like shoe size and your height. Okay, so maybe no matter what your shoe size, maybe every person that has a shoe size of 7 could be any height for the y. Okay, that's not the best example there, but we'll actually get more into the real life examples as we kind of get down the basic parts of graphing, and then we'll bring in the real life examples to kind of tie it all in together. So that's 28, different than 25, and that was 25 where we saw a horizontal line. And the last question here in your homework, you do have a fraction, don't be scared by it. Number 29, we have y equals 3 over 2x plus 5. Okay, when you go to make your chart, okay, my suggestion to you is as you pick your x and y's, your x's, because you're going to multiply your x with this fraction 3 over 2, and some of us might want to change it to y equals 1.5 times x plus 5. We can do that. You can change it to 1.5 when you're multiplying. But because they're in halves, like 3 halves, it's nice to pick x's that are that will multiply with a whole number. So if you multiply two halves, then you get a whole number. So if I pick 0, that's a good number because it's just going to cancel out 0. If I pick 2, then when I multiply halves with 2, I will end up with wholes. Or if I pick like 4, then if I have 4, then I don't have to work with halves when I go to graph. I hope that kind of makes sense. But you'll see that, let me show you when I actually choose these numbers. So for 0, y is equal to 3 halves times 0 plus 5. So 3 halves times 0 plus 5 means 3 halves times 0 is just 0. So 0 plus 5 is just 5. So my first ordered pair is 0, 5. So that's nice and whole, no decimals, and I don't want to have to work with decimals. Then again, I'm going to do y is equal to 3 halves times 2. Now if I multiply 3 halves times 2, I'm going to make the 2 a 2 over 1. What I can see here is I can cancel out the 2's, which 3 halves times 2 is actually 3. So I'm going to, add that with 5. So here, I'm going to have 3 plus 5. So it gives me a nice whole number, which is actually 2, 8. So I'm going to have 8 as my y. I know I'm working a little fast, crunching down here on this video. Y is equal to, my next one is 3 halves times 4. I'm going to change the 4 to 4 over 1, and then I'm going to add 5. So if I work that out, what I'm going to get is I'm going to cancel the 2 and the 4 and get 1 and 2. So 3 times 2 is 6 over 1, which then I'm going to add with the 5. So 6 plus 5 is equal to 11. So my next solution is 4, 11. See how I don't have to deal with 0.5s or halves? And if you chose different numbers, it's okay, because go ahead and look at the graph that I'm going to get. My numbers have to be pretty big because of the 11 here. So what I'm going to do is I'm going to do 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. So that's 12, 12, 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. I don't think I need any of the negatives. So I've got 0, 5, 2, 4, 5, 2, 8, 2, 4, 5, 8, and then 4, 11, so 4, and then right here. So you can see my dots are starting to line up really nice, because as I put my ruler here, I'm extending my line past the dots. I've got a nice straight line. All my answers look really good. Mine are all in the whole numbers. Yours might just have decimals and halves, and that's totally fine when you go to graph it. But your graph will look like this upward sloping line, diagonally speaking. We'll see you tomorrow, and we will talk about more about 29 and 25 and 28, and we'll see you tomorrow.